Hello.
Yeah, hello. Yeah, hi, Richard.
Yeah, hi, sir. Good
Hi.
afternoon.
Good afternoon. So previous class we studied about that limits, right? In the previous math class we studied about the limits.
Right, sir.
So tell me, what are the three methods for finding the limits?
First is direct substitution.
Direct substitution method,
Then,
okay.
then factorization,
Then
and the exponent form. I don't know how to say.
what is the
The
formula for it?
x raised to the power n minus a to the power n by n.
By
I don't know. Is it n?
it is x minus a.
Oh, x minus a. Sorry, right.
Because when you substitute x as a, you will get 0 by 0 form, right?
Right.
You have to see it. So what is the formula for it? What is the formula?
A. I don't remember.
You have to remember
Sorry,
actually.
sir. Yes, sir. I'll practice it. Sorry.
So it is n into a to the power n minus 1.
Okay.
Okay. If you don't remember also, it's fine. When we study about
Okay.
derivatives, directly you will remember this.
Okay.
Because limits and derivatives both are same type. That's it. There is no difference. Just derivatives is nothing but the shortest form of finding the limits. That's it. And we have pre-described formulas for it. Just we have to remember. But remembering those formulas is a must.
Okay.
The derivatives. So now solve the first question. Yeah, after this we have the trigonometric limits, right?
Yeah. Sin x by.
So limit x tends to 0. Okay. Instead of limit LIM, I can write it as LT also. That's it.
Okay.
Limit LT. This is another form of writing a limit. That's it. So limit x tends to 0.
So do you want me to say?
Yeah, you have to tell.
Yeah, our sin x by x is equal to 1.
The next cosine trigonometry.
Yeah, 1 plus cos x by x is equal to 0.
This one. Right?
Yeah.
Okay, now. Tell. First one. So first one you will do by which method? Yeah, these are the questions.
Okay.
So what is the answer for the first question? Okay, how to solve it?
So we can use direct substitution, right?
Yeah. First, we have to direct substitution. If it comes 0 by 0, then we have to go for factorization. If factorization is difficult, then we have to see whether it is in the form of x power n minus a power n by x minus a form. If it's in trigonometry, we have to convert it to sin x by x or 1 minus cos x by x. 1 plus cos x by, okay?
Yeah, okay. So for the second one, x tends to what? Because you haven't written any 1. Okay.
Wait, if x tends to 1, it becomes difficult because you have to do that in differentiation. X tends to minus 1.
Okay.
So first one, how much is the direct substitution? How much is the answer for the first one?
19 by 2.
19 by 2 directly. No, next. So first question done. Next one.
Second is 1 by 2.
So second we got the, so when you substitute that x as 1 by minus 1, right?
Yeah.
How much
So
you
it'll be
get?
1 minus 1 by 2.
1 by 2. Let's see. X power 10 is 1.
1
Minus 1 plus 1.
Plus, yeah.
Divided
By
by
minus. Oh, sorry. It'll be minus 1 by 2.
minus 1 by 2. Okay. Now
Yeah.
the next one.
So we can also, what do we do for this one?
If you're substituting direct substitution, it is coming
You get
0 by 0, right?
Yeah.
If you want to factorize it, it is to the power 8. We can't factorize it very easily.
Yeah.
Now, since there is a power on that, it's somewhere resemblance to x power n minus a power n by x minus a. Okay?
Okay.
Means you have to somehow convert the whole expression to this form, right?
Right.
So then you have to think, if we assume that x plus 1 as y, we did this in last class.
Oh, yeah. Okay.
So if x plus 1 equals to y, then
y to the power 8 minus 1 by.
So limit here y tends to, when x is 0, value of y is 1, right?
Yeah.
So here y to the power 8 minus 1 by, what is x?
Minus x 1. Will be y minus 1.
So it is 1 power 8, right? The same. So x power n minus a power n by x minus a. It's in the same form?
Yeah.
So formula.
So is the answer 8?
Yeah, the answer is 8. N into a to the power n minus 1. See it correctly. That is nothing but 8. No, 8. Because 1 to the power anything is the same value, right?
Right.
Now, the next question. Fourth one. First, direct substitution. If you do direct substitution, it comes 0 by 0.
So we use factorization, right?
So we use factorization method.
So is it 11 by 4?
How you got 11 by 4?
Yeah, so 11 by 4. I factorized it. So you'll get the factors as 3x plus 5 and x minus 2. Divided by x plus 2.
Then if you substitute, you will get as 11 by 4.
By 4.
Okay, no. I think you know the trigonometric compound angles, right?
Yeah. The sine.
Yeah, the
theta
sine, the relation between sine theta and cos theta and the half angles of that.
Oh, so what is half angle?
That is theta by 2. That is half angle. We will do this. What is sine 2 theta formula?
I don't know.
Okay.
Oh, wait, so is this compound and multiple angles?
Yeah, it's the component matter. What is sine 2 theta?
Oh, yeah, so I don't know because I
Okay.
haven't studied this chapter.
Okay. It is 2 sine theta cos theta.
Okay.
You have derivation for it. That no need. You have to remember. Sine 2 theta is 2 sine theta cos theta. Okay. Now,
Okay.
instead of 2 theta, I just taken theta. Right?
Mm.
Here,
Yeah.
if it is 2 theta, I am getting theta and theta. That is half of 2 theta, right? If
Right.
here it is theta, it becomes 2 sine theta. It should be half of this theta. That's why 2 sine theta by 2
Okay.
cos theta by 2. That's it. These are called the half angles. That's it.
Okay.
Because while doing the limits, these are useful.
Okay.
Because we have to convert from sine anyhow, from sine to cos, right?
Right.
So limit x tends to 0, sine 4x by sine 8x.
So how do we do this?
So this is in the sine limits, right? So what? So whenever there is a sine, cos, there is a standard form. Always you have to get sine x by x forms. That's it.
X.
Okay.
Okay.
X in the sense, if it is sine ax, it should be in ax. That is the main. Means the angle should be same. Okay.
Okay.
Now here it is 4x. Means in the denominator also I should get 4x.
Yeah.
So what I will do is I will multiply and divide it with 4x.
Okay.
So instead of doing this in all one thing, I will just divide it into 2 parts. Just for clarity, otherwise you can do it directly. So when we are studying about the properties of these limits, what we studied, limit of f by g. Limit of f by g means division, means we can apply the limits to both, right? The numerator and denominator separately, correct?
Right. Right.
Now we will use this concept over here. Okay, instead of writing in the denominator, I will just take it that side and I will put it a division symbol, just to be simple. Sine 4x divided by limit x tends to 0, sine 8x, correct?
Yeah.
Now I should get, here in the denominator, I should get 4x, right?
Right.
If I write 4x over here, the value will change. So that's why what I will do, I will just multiply it with 4x. Then the value won't change, right?
Right.
In the, here also I will do multiplied by 8x, multiplied by 8x, okay?
Okay.
Now, if I take, this is also in multiplication, I can apply limits separately, right? Limit x tends to 0 of 4x, limit x tends to 0, sine 4x by 4x divided by limit x tends to 0 of 8x, limit x tends to 0, sine 8x by 8x, correct?
Right.
I can write this whole thing as 1. It is of the form sine x by x.
So it'll be equal to 1.
Here also it is equals to 1. So we got limit x tends to 0 of 4x divided by, don't substitute 0, otherwise again you will get 0 by 0 only.
Yeah.
Limit x tends to 0 of 8x, right?
Yeah.
Now I'm just combining it, because if I can divide, I can combine, like limit x tends to 0, 4x divided by 8x, I can write it as by 8x directly, right?
Right.
Now I can cancel x and x.
1 by 2.
So that is 4 by, that is 1, because limit of a constant is the same number itself.
Right.
Okay.
Okay.
Now here this is an elaborated way. Now if we do the same thing in directly. So here we got limit x tends to 0 sine 4x by sine 8x, right? So here
Yeah.
I can write by 4x into 4x
Yes.
by 8x into 8x, right?
Yeah.
Now directly after substituting this 4x by 8x, here I can cancel x and x directly over here, and limit x tends to 0 is 1, here is also 1. So directly we'll get 4 by 8, which is equals to 1 by 2.
Thank you.
In the beginning stages, we have to do it like this, but when you are perfect, directly we have to do within 2 steps.
Okay.
In some cases, you have to do without writing also. Without writing a single step, we have to tell the answer. Okay.
Okay.
And that is possible. Just it's a matter of practice. That's it. We have to know what to do. That's it. Okay, understood this one?
Yes. Yeah.
No. Limit of x tends to 4 sine of 4 minus x by 4 into 4 minus x.
So here you multiply and divide with 4, right?
Why I have to multiply and divide by 4? What is within the angle?
4 minus x.
I have to get 4 minus 6 in the denominator. That is the main motto, right?
Yeah.
4 minus 6 is already in the denominator. Then why I have to multiply?
Yeah. No, I'm saying multiply and divide 4, not 4 minus x.
Why multiply and divide by 4? Okay, if I multiply and
Because you
divide
have
by
to
4,
remove the 4, right?
directly you can take 4 outside. It's a constant.
Oh, okay. So you'll get 1 by 4.
This is the whole thing. It is same as 1.
Mm.
So any constants, you can take it out. No need to multiply and divide. No need to apply limits to this. Any constant, just take it out. Okay?
Okay.
No, this one. Limit x tends to 0 cos 2x minus 1 by cos x minus 1. If you want to apply this cos limit, you have to get 1 plus cos x by x, right?
Right.
Is it 1 plus cos x by x or 1 minus cos x by x?
1 plus cos x by x, right?
No, you have to So first think, then I will tell whether it is correct or not. You have to analyze whether how you are getting limit x tends to 0 sin x by x. When you substitute 0 over here, it is 0 by 0. 0 by
Right.
0 indeterminate form, that's why 1. Okay.
Okay.
Now limit x tends to 0. If you take 1 plus cos x by x, substitute x as 0.
So you get 1 plus 1
What is cos
by
0? It is 1 by 0, right?
Oh,
It's not 0 by 0
right.
form.
Yeah.
You will get as 0 by 0. As a normal remembering, that's it. Whenever you get 0 by 0, then only it gets to 1 or equal to 0. Okay.
Okay.
So here it is 1 minus cos x by x.
Okay.
Now if you see this, here it is cos x minus 1, but here it is 1 minus cos x.
Right. So do we take the negative out?
Let's try to take the negative outside. So it becomes limit x tends to 0. I can write minus of 1 minus cos 2x, right?
Yeah.
By
By
minus of 1
1.
minus cos x. Correct?
Right.
So then if I cancel this, then I will get limit x tends to 0. Here I should get x, right? That is the coefficient of this
Right.
one.
Yeah.
If I take it by 2x into 2x by x into x, I can cancel this 2 and 2. I will get 2 outside. Okay. What is 1 minus cos 2x by 2x?
0, right?
Again, you're getting 0 by 0 form only. Right?
Right.
After converting to 1 minus cos x by x also, we're getting the same 0 by 0, that is indeterminate form. Correct?
Right. Yeah.
So here, just you have to convert. Instead of cos, take the sine. Okay?
Okay.
So here you have to remember that trigonometric identity. Okay?
Okay.
As cos 2x equals to 1 minus 2 sine square x. You have to remember this.
Okay.
Okay?
Okay.
Means how can you write cos 2x minus 1 as?
1 minus 2 sine square x minus 1.
Now we need cos 2x minus 1, right?
Right.
So cos 2x minus 1, it comes as
Oh, such minus
minus
2 sine
2 sine square x.
square.
Okay? See,
Okay.
here it is 2x, then you will get x. Okay?
Okay. Okay.
Now substitute this. If you go do minus minus, minus minus gets cancelled. We will write it, then we will cancel it afterwards. Limit x tends to 0. What is cos 2x minus 1?
Minus 2 sine square x.
Minus 2 sine square x. Okay. Divided by. Now what about this?
So here,
Cos,
sir, will it be sine square 2x?
yeah, minus 2 sine square
2x.
by 2x.
Is it 2x?
It
I
is
don't know.
becoming half. It is becoming
Right.
half.
Oh, so
See here.
x by 2.
X by 2.
Okay.
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 Now you can cancel this 2, this 2. You can cancel 2 also because it's the constant, right?
Right.
So limit x tends to 0. We have sine square x by sine square x by 2. Okay.
Okay.
Now don't think whether it is sin x or sin square x or sin cube.
Okay.
Whatever it is x square, so in the denominator also we should get x square. That's it.
Okay.
Okay. So now here what we will do is same thing. Here it is in the angle we have x square. So I am dividing with x square, multiplying with x square. Okay.
Okay.
So here what is in the angle over here?
X. The numerator will be x and denominator will be. So for denominator, what we multiplied with x only?
No, what is in the angle? That's
Oh,
it.
x by 2.
X by 2. Wait,
Right.
we will separate this. So note
Okay.
down this formula. Cos 2x
Yeah, I
is
wrote.
1 minus 2 sin square x. Okay.
Okay.
Now we will just separate instead of writing all one place. Just separate it. After some time, then you can write it all once. Okay. So which is equals to limit x tends to 0. Separate it. Sin square x divided by limit x tends to 0. Sin square x by 2.
X by 2.
Correct?
Yeah.
So no. So limit x tends to 0. I will multiply over here. Divided by x square multiplied by x square. Correct?
Yeah. So why are we taking x square?
So here it is sin square x, right? Means the x is in
Right.
square. That's why.
Oh, okay.
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 Here it is, if it is sin 4x, then you are multiplying with 4x and 4x, right?
Right.
Whatever the angle, you are multiplying it over here. So here it is, if it is sin square x, then you have to multiply it by x square and x square, because in the angle it is x to the square. Okay. Here it is, if it is cube, if it is sin to the power 4x, then we have to multiply x power 4 and x power 4, because the power of this is 4. Here they are just writing this power to the sin, not for the x.
Okay.
Whenever it is sin power 4x, means it is the angle to the power 4. Okay.
Okay.
Now just we will solve this. So multiplying x square and x square, and for the second term, what I have to multiply?
X square by 4, right?
That is x by 2 whole square, x by 2 whole square.
Yeah.
Okay, x by 2 whole square. Here also multiplied with x by 2 whole square. Okay.
Okay.
Now it is limit x tends to x square, limit x tends to 0 of sin square x by x square, correct? Divided by limit x
So what
tends
do you
to,
say?
no, just I am writing dividing this. Limit of AB is limit A into limit B.
Right.
So limit x tends to 0 of x by 2 whole square, limit x tends to 0 sin square x by 2 by x by 2 whole square. Right?
Yes, sir.
Now if it is sin x by x, it is 1.
1.
If it is sin square by x square, it is nothing but 1 square itself. Just you're taking whole thing common and writing square, that's it. See this.
Okay.
Sin square x by x square, it is nothing but sin x by x whole square. Okay.
Okay.
For this purpose only, we have taken x square in the denominator instead of taking x. Because when you take common, you should get sin x by x form. Okay.
Okay. Okay.
And sin x by x, we know it, the value is 1.
Right.
So now, after knowing sin x by x, so then it is just as a calculation part. This whole thing becomes 1. Right?
So which, yeah, that becomes 1, and the other one also becomes 1.
Now what is the remaining? Limit x
So
tends to
limit
0,
of x
x
square
square,
divided by x by 2 the whole square, or x minus 1.
right?
Yeah.
Now that till the next step. Now you just combine it. Limit x tends to 0 of x square by x
X
square
square by
when
4.
by 4. By 4 means it goes on the top, right?
Right.
Understood this one? That 4 went
Yeah.
upside. So x square gets cancelled.
So it will be equal to 4.
This is a constant value, 4.
Okay.
Okay?
Okay.
Understood this?
Yeah.
So the first step of proceeding this one is by substituting the trigonometric identity. Okay?
Okay.
That is 1 cos 2x minus 1 cos 2x equals to
1 minus 2 sine square x.
1 minus 2 sine square x. Okay? Remember the identity. Wherever you see cos 2x, you can substitute this. Okay?
Okay.
No. How to solve this one? Limit x tends to 0, ax plus x cos x divided by b sin x. When you see sin and cos, the only thing that your mind should strike is it should come in sin x by x form or 1 minus cos x by x form, right?
Right.
Now here it is 1 plus cos x, so we can't change the sign of a cos. So maximum cases you have to take it in sin x by x. Okay.
Okay.
Now if you substitute it directly, what you will get? 0 by 0.
Will be 0. Yeah, 0 by 0.
Now let's see factorization method. Factorization is nothing but you are taking things common, right? Outside
Right.
from the big one. Now let's see whether we can take any common from this. There is x over here, x over here. I can take x common.
Yeah.
So limit x tends to 0. I will take, if I take x common, what is the left out? A plus cos x
A plus cos x.
by b sin x, right?
Right.
Now whether it can be sin x by x, otherwise I can reverse it by just division, x by sin x, right? Now
Right.
if I see it over here, there is x by sin x.
Okay.
Correct?
Okay. Yeah. So that'll be also equal to
Now we
1,
can just
right?
separate it. Now I will separate it. Limit x tends to 0, x by sin x. We will take x by sin x after, because after division it becomes sin x by x, right?
Right.
So x tends to 0. Here we have a plus cos x divided by b. That is a left out thing, right?
Yeah.
Into x by sin x, correct?
Correct.
I can apply limit. This is the next step. Applying limit to the second function
Yeah.
also. So now limit x tends to 0. Once you know this, then it's all just a breeze. That's it. Cos x by x. In multiplication, I can make it to division, right?
Right.
Sin x by x.
But
Correct?
sir, do we have to divide it? Because won't the inverse of sin x by x be equal to 1 only?
Yes. You have to show this. Although you know limit x tends to 0, x by sin x is 1.
Yeah. Yeah.
This one we don't
Oh,
know
we have
whether
to
it is
show it.
actually equals to 1 or not. We don't know that.
Okay.
We are making it is into division. Then we have sin
Okay.
x by x. We have the formula for sin x by x, not for x by sin x,
Sin
right?
x. Okay. Yeah.
Both are different. Sin x by x is different. X by sin x is different function. Okay.
Right. Okay.
Always you have to get it in standard forms. That is sin x by x. Okay.
Okay.
So that's why you are doing division over here for taking it into a standard form. That is sin x by x. Okay.
Okay.
Now we know the value of this is 1.
Right.
Now
So
divided by
we
1
can.
is the same value. If you substitute
Okay.
0, a plus cos 0 by
Oops.
b. Now it is not an indeterminate form.
Mm.
We can do it directly. What is it?
Is it a plus 1 by b?
That's it. A plus 1 by b. Just as a simplification. So
Okay.
understood? First you
Yeah.
have to see whether you can do it by direct substitution. If it is coming 0 by 0, then go for factorization. Factorization, it doesn't mean only power 2 and we have to do it by middle term split method. You can taking common is also considered as a factorization. Okay. That's why you
Okay.
have to check whether there is anything common or not. Now there is common. If anything is common, just take it out.
Okay.
Then we got x by sin x. We can convert it to sin x by x by just keeping a division symbol, right?
Right.
Then we can proceed it directly.
Okay.
All are just as a calculation part, just what you have to modify to another to the standard forms. That's it.
Okay.
Now in the same way, this is one as a normal modification type. Okay. This is not as a modification. What is limit x tends to 0 of x secant x? You know about the trigonometric, the total there are 6. Sine, tan, sine, cos, tan, cosecant,
Right.
secant, and cot.
What?
Did we study limit of any secant functions, tan functions? No, right?
So what did you say? Your voice is breaking.
Did we study sine or cos, tan, or only sine and cos?
So only sin and cos, right?
So if you are getting any other trigonometric ratio other than sine and cos, just you have to
Right.
convert it to sine and cos. That's it.
Okay.
So now what is the secant x equal to?
1 by cos x.
1 by cos x. Just substitute over here.
So
Limit
x
x
by
tends to
cos
0, x by cos x.
x.
So substitute it. When x is 0, it is 0. When x
By
is 0, 1,
0 by 1.
that is 0 itself.
Okay.
If it is in the denominator, it should not get 0. But here it is 1. So it is not an undeterminate form, right?
Right.
That's why the answer is 0 directly.
Okay.
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 Limit x tends to 0. Sine ax plus bx divided by ax plus sine bx. What is the limit?
So we need to remove the sign from dx, right, in the denominator.
Yeah.
So
If you can't remove, just multiply, because when you simplify it, if they are in numerator and denominator, automatically they will get cancel each other. Okay.
Okay.
Just multiply, because we need ax on the top, bx on the bottom, right?
Right.
So what I will just multiply ax over here and bx over here divided by ax into ax, correct?
Right.
Not for the whole expression. I am doing only for this sine ax.
Yeah.
Divided by bx multiplied by bx. Okay.
Okay.
It all depends upon how we write it cautiously. If you do the whole denominator, then in the end you will get the same answer itself. But the calculation becomes tricky. That's it.
Okay.
So which equals to limit x tends to 0.
Ax
Okay, we will separate
plus
it. Instead of doing this, ax into sine ax by ax plus bx. Okay.
okay.
Divided by limit x tends
Ax
to 0,
plus yeah.
ax
Ax
plus sine
yeah.
bx
Ax
by
by
bx into bx.
into bx.
Correct?
Yeah.
Now, just go on using the properties of limits. If it is
Right.
multiplication, you can give the limit to all the multiples. If it is addition, you have to give it to the addition itself. So limit x tends to 0 of ax into limit x tends to 0 sine ax by ax
Ax by
plus limit x tends to
plus
0
limit extends of
bx.
x.
That's it. You are not giving limits to all.
Okay.
Limit x tends to 0 ax plus
Plus
limit x tends to 0 sine bx by bx
by
into limit x tends to 0 bx.
x.
Now we know what will happen. This all becomes 1.
1.
This all becomes 1. Right?
Yeah.
Which is equals to limit x tends to 0. Now tell the expression.
Ax plus bx divided by ax plus bx.
So ax plus bx divided by ax plus bx. Total are same.
Yeah, so 1.
This is the answer. Okay.
Okay.
We didn't do anything. Just what we did, we are just separating it, and
Yeah.
we was doing applying the limits. That's it. It's as simple
Okay.
as that. Okay. No. Limit x tends to 0. cosecant x minus cot x. What is the first step that we have to do?
So we convert it into cos and sine.
Yeah, we have to
So
convert in cos and sine.
yeah. So we get the final expression would be limit x tends to 0 of sin x minus cos x by sin x square.
Sin x
No, sin
minus.
x. No, sorry.
Why
It'll just
sin
be
x
1
minus?
minus cos x by
1
sin
minus
x. Cos x by sin x.
cos x by sin x. Right?
Yeah.
Now what we know?
Uh,
We know the limits, right? Sin x by x is 1 minus cos x by x is 0. It is in both form. There is sin x, there is 1 minus cos x.
right.
Right? Just what you have to do. Total thing by x into x by x into x. That's it.
Okay.
Are we doing anything different over here? We are getting one. We have to get 1 minus cos x by x. I have 1 minus cos x. For getting by x, I am just dividing x, multiplying x. Same thing for sin x, dividing x, multiplying x. That's it, right?
Yeah.
So instead of next step, we will cancel x over here because wherever you cancel is the same, right?
Right.
So now I can apply limit separately. Limit x tends to 0, 1 minus cos x by x whole divided by limit x tends to 0, sin x by x. Directly they're in standard form, right?
So 0. Yeah.
0 by 1, which is 0.
1, 0.
That's it. If it comes 0 by 0, then we have to go by another methods, right?
Right. So what is the other method we would use?
No,
If it's
this
0
is the
by
only
0?
method. Yeah, 0 by
Okay.
0. If it comes 0 by 0, we have to use it by factorization method. That is first one.
Okay. But so there's nothing common between 1 minus cos x and sin x, right?
Yeah, but this is in the standard form directly, right? Sin x
Right.
by x is the standard form. 1
Right.
minus cos x by x, the standard form.
Right.
This is directly will get in standard form. If you
Okay.
don't want to do in this method, we have the another formula. That is 1 minus cos x is equals to 2 sine square x by 2.
Oh, okay.
Okay. It's the same
Okay.
thing. Cos 2x equal to 1 minus 2 sine square x, right?
Yeah.
I just reframed it. 1 minus cos x equal to 2 sine square x by 2.
X by 2.
Okay.
Okay.
But mostly what you have to do is you have to get the given expression in standard form. Here already they are in standard form. Again, why you have to convert into another form and calculate that one? There is no use, right?
Yeah.
If anything is in standard form or it is similar to standard form, we will solve it directly because it's simple. If anything is not, then we are doing modifications for getting it into the standard form. The main motto is at the end, we should have standard form. That's it.
Right. Okay.
So here we got the answer 0 by 1, which is 0.
0.
Okay.
Okay.
These are the different types of the limits that questions they will ask. In all cases, we are doing only one thing. We are converting the given expression in standard form. That's it. For that purpose, we are using different techniques. We are taking common, or we are converting from sine to cos, or from tan to sine theta by cos theta, like that. That's it. Okay. That's all limits. Okay. I will send some other questions in the limits for practice. Okay.
Okay, sir. Okay.
No. You know this modulus function that is called mod x. So what does this modulus function does?
It gives the magnitude, right?
It gives the magnitude.
Like, yeah.
Means in general, the modulus function gives only the magnitude. That is, it gives only positive values.
Yeah.
Correct? Positive values.
Yeah. Yeah.
Means modulus of minus x is also x. That is the meaning, right?
Yeah.
Now, how to represent this one? By using this range method. Let us suppose modulus of x equals to x. When x is greater than 0 and modulus of x equal to minus x. When x is less than 0. Can I write like this one?
Yeah.
Because when x is less than 0, I have to take minus of, because obviously the x is negative, minus of minus will come as plus, right?
Right.
So modulus of x means, if modulus of x equal to x when x is greater than 0, and modulus of x equals to minus x when x is less than 0.
0.
Okay.
Okay.
Then why you are studying this over here? Let's see. Because just as one concept, whether the limit exists or not. That's it.
Okay.
Let us suppose they gave a function like this. Limit x tends to 0 of modulus of x, that is f of x. With particular limit x tends to of f of x, where f of x is defined as mod x when x is greater than or equal to 0 and minus x when x is less than or equal to 0. Okay.
Okay.
Now we have to tell whether the limit exists. Whether limit exists or not. So exists or not. So where we have to check? They didn't give the limit point, right?
Right.
They gave. What is this? Limit x tends to
0, 0.
This is
Oh,
the
yeah,
limiting point.
0. Yeah.
So you have to find whether the limit exists or not at x equal to 0. Means at x equals to 0. What I told, for limit to exist,
LHL should be equal to RHL.
To RHL. LHL is nothing but, here it is 0, that is a minus should be equal to a plus, the limit. Right?
Right. Yeah.
Now, how to check? For this type of conditions, assume, so since it is 0, right, over here,
right,
whatever value you are taking in negative, the same value you have to take it in positive because the distance should be same. Okay.
Okay.
If you are taking as minus 0.3, you have to take right hand limit as 0.3. Okay.
Okay.
Now how solution? We have to prove. Proving is nothing but left hand limit should be equal to right hand limit, right?
Yeah.
Means limit of x tends to 0 minus should be equal to limit x tends to 0 plus. Right?
Right.
I am taking one value of x in left hand limit as minus 0.4. Okay.
Okay.
Now what is the left hand limit? Calculate.
So calculate.
Limit x tends to minus 0.4, right?
Right.
When the value of x is minus 0.4, what is the value of f of x?
It'll be minus x. So minus 0.4. So I don't understand. When x is minus 0.4,
What is
you
f of
asked me to
x?
calculate
Yeah, what is
y.
f of x? That's it. Yeah.
So, yeah.
When x is minus 0.4, what is
So,
the value of f of x? That's it.
is it 0.4?
Yeah, because it is minus of minus 0.4, right? Because it is minus
Right.
x, correct?
Yeah.
So minus
Yeah.
and x is minus 0.4. We will get 0.4. Because since x is minus, that is x less than 0, right? We
Right.
have to take minus x function. Okay.
Okay.
Instead of mod x, they give directly as x also is the same answer. Now the right hand limit. When x is 0.4, so the right hand
Y is
limit is
0.
directly equal to 0.4. So left hand limit is equals to right hand limit.
So limit
0.4, 0.4. So limit exists.
So can we just take one value, or do we have to take like more than one value?
No, only one value is fine.
One is enough. Okay.
Yeah, one is enough. When they give these type of functions like x greater than 0 and x less than 0, means they have divided into intervals, positive interval, negative interval. Then with only one value, it is enough. If they gave only one function,
right,
like let's suppose
then
they give this, yeah, you have to take 2 above, 2 below, total of, and 1 for the x value that they will be asking. Okay.
Okay.
If they will get x squared, that's it. Then you have to take total of 5 values: 2 for left hand side, 2 for right hand side, 1 for the at x equals to a value. Okay.
Okay.
This is just for finding whether the limit exists or not when they have given the function in separated intervals. Okay.
Okay.
Now, let's come to the differentiation part. This is just limits. There is nothing much in this.
Okay.
Differentiation. Before proceeding to differentiation, so just one thing is, differentiation is nothing but the slope of a graph directly. Okay. It is the slope of a graph. Slope in the sense, it is nothing but the, if it is a normal straight line, then we have the slope is constant. Slope is nothing but, if there, suppose this is theta, yeah, we'll take y2, we'll take that one. Here it is x2, y2. x1, y1. Then we have this formula for slope. That is y2 minus y1 by
y1 by x2 minus
x2
x1.
minus x1. This is the formula for slope. And slope is also equals to the tan theta.
Yeah.
Right? If this is theta over here, so it is equal to the tan theta, correct?
Tan theta. Yeah.
Now, this here, wherever you take, the theta is constant. Here also, if you take the theta is same. Here also, if you calculate the theta is same, right?
Right. Yeah.
Means the slope is constant for this line, right?
Yeah.
Or you can say the slope is same because it is a straight line, right?
Right.
Now, when the graph is curvilinear, if it is like this, then at this particular point, we have one slope. Right?
Right.
Okay, what I told, slope means y2 minus 1 by x2 minus x1, right? Now,
right.
The slope of a curve, since it is a straight line, it is a direct one single slope. The slope of a curve is nothing but the tangent drawn at that line. That is nothing but tan theta. That's why we're calling us tan theta. Okay. The tangent drawn at that point to the curve. Okay.
Okay.
Suppose there is curve over here like this. At this point, if you draw a tangent means it has to touch, right? Just it has to touch. It should not cut the curve. Just it has to touch it. That's it. That is called the tangent. If you want to draw a tangent at this point, just it has to touch it. Right?
Okay. Yeah.
It should not cut the curve, remember. Okay?
Yeah. Okay.
So only it has to touch. Okay?
Okay.
Now, let us suppose for this curve, if you want to find the slope by using y2 minus y1 by x2 minus x1. So here it is x1, y1. Here it is x2, y2. The formula is y2 minus y1 by x2 minus x1. If you draw this line, it is cutting the curve, right?
Right.
So what we will do is, so in general, how we got this y2 minus y1 also, there is some simple trick. Just we are making a triangle. This is one triangle type. Till here it is x1. Till here it is x2, right? Now what should be this distance? x2 minus x1, correct?
Minus x1. Yeah.
So x2 minus x1. Now same way, till here it is y1, till here it is y2. So what is this distance? y2 minus y1. This is the theta, right? Now same thing. What is tan theta? Opposite by adjacent. y2 minus y1 by x2 minus x1. Actually, this is the way how it derived. How this tan theta is equals to y2 minus y1 by x2 minus x1. Okay?
Okay.
So now for taking as a triangle, it has to be the tangent. But here it is cutting, right?
Right.
So then what we will do is, we have to take y2 minus y1, x2 minus x1. But it should not cut the curve. That is the condition.
Okay.
So what we will do is, we will just take the 2 points, which is very near to this. This is the curve. We are taking 2 points over here as x1, y1, just adjacent to it, x2, y2. Okay?
Okay.
Here the difference is very small. Just you are taking just adjacent to it. Okay? Now if you draw if you join these 2 points, then it becomes the tangent, right?
Right.
Now also, if you want to calculate this as a small, there will be a small theta, right?
Right.
So the tan theta, if you calculate the same formula, y2 minus 1 by x2 minus x1, since it is very just adjacent, if you take the difference of it, it is very, very small, like similar to 0, right?
Right.
It's very small, right?
Right.
So in max, when the physical quantity is very, very small, we will represent it with d, that is the differentiation, dy.
Differentiation.
Okay.
Okay.
When the
Okay.
change, when the difference is very, very small, very minute, which is similar to 0, we will take it as d. Okay.
Okay. Okay.
dy by, here also very, very small in
D.
x, dx.
Right.
So we have directly formula tan theta equals to dy by dx for the curve.
Yes.
Okay. This is how
Okay.
this differentiation, that tan theta equal to dy by dx arrived. Okay.
Okay.
Now the same thing, they are just representing in a formula base. That's it. Now let's see this. How they came to the formula. This is the actual physical representation when you're dealing with graphs and all.
Okay.
Okay. We can understand thoroughly when we study it with graphs. That's why we started with graphs. Then is the normal what is the formula of it and all. It's very simple. Okay. Now let's see this. Let's take the same straight line here itself. Otherwise, it should be because we're studying, because in physics or in any physical world, it's not only about the linear graphs, not only the straight line graphs. We have many curves and curvy linears also.
Okay.
So you have to study for the generalized forms. So here, let us suppose this is a function of f of x. Okay.
Okay.
So y equals to f of x, correct?
Right.
Now we are taking two values, that f of x is over here. So just adjacent to this. So if I write this one, I can write it as x comma f of x, right?
Right.
Now just adjacent to it. Instead of taking adjacent, I am taking at a place the difference between this x and the second one. X plus h. Okay.
So I don't understand what. Oh, okay.
So here,
H is the distance between. Okay.
x is the distance, right? From there, h is the distance between the previous value of x.
Okay.
So
Okay.
I am just
Got
taking some value over here at a distance of, this is x, this is x plus h. Okay.
Okay.
Then what is the point over here? X plus h comma f of x plus h, correct?
Right.
So now what I told, it has to be very small, right? The difference.
Right. Yeah.
Means the h has to be very small.
Right.
Correct. Very small means it has to tends to 0. Correct.
Yeah.
Tending to 0 in the sense it is very, very small. That is the meaning. That's it. Okay.
Okay. Okay.
Now, what I have to find is the limit, that is f of s plus h, limit of f of x plus h. Okay.
Okay.
Okay. Now tell me, what is the differentiation formula? By using y2 minus y1 by x2 minus x1. That's it.
So dy by dx.
So dy by dx. So what is y2 over here?
F of x plus h.
F of x plus h. This is y2 minus, what is y1?
F of x.
F of x by, what is x2 minus x1?
H.
So that is x plus h minus, that is h, right?
H minus. Yeah.
So this is the limit, right? This is the differentiation that when we are studying in graphical notation, right?
Right.
So when we can tell this is differentiation when the h is very, very small, correct?
Right.
So I can write it as limit h tends to 0. Means when the limit
0.
is, when the limit of h, it is very small.
Yeah.
Means when the limit of h is tending to 0, then it becomes the differentiation, correct?
Right.
This is a representation of f dash of x. That's it. F dash of x. This is nothing but dy by dx. This is the differentiation. How we got this formula. This is the formula for calculating the differentiation. This is called as first principle. Okay.
Okay.
The name of this is called first principle of differentiation.
Okay.
So what we can, this is same as y2 minus y1 by x2 minus x1. It has to come. That is same as the differentiation dy by dx, correct?
So can you just give me 1 minute? I just have to charge the laptop. Just 1 second.
Yeah, okay.
Yes.
So first what we did, y2 minus y1, that is f of x plus h minus f of x divided by x2 minus x1, that is h, right?
Right. Yeah.
When this h is very small, that is limit of h tending to 0, then this whole thing we are telling it as a slope, right?
Right.
The slope is nothing but, as we told before, it is the differentiation. So if it is f of x, the representation of differentiation of f of x is f dash of x. Okay, it is read as f dash of x.
X.
Okay.
Okay.
It is called as f dash of x. This is nothing but the differentiation. You means you are applying the limit. That's why you studied limits in the before. First, what we do is just first we find out the slope. Then after finding the slope, when you calculate, if h is very big, it is cutting the curve, but the tangent should not cut the curve. So the condition we are implying over here is the h that what we are taking, it should be very like it should be infinitesimally small. That means h should be tending to 0. So when limit h tends to 0 of this function, it gives the differentiation. Okay.
Okay.
Now this is useful for finding the differentiation by first principle. Okay. When they ask find the differentiation of some function by using first principle, you have to use this.
Okay.
Very lengthy process, but we have to do only 2 questions on this. The rest we have to remember the formulas because they won't ask the derivations for the standard forms. Okay.
Okay.
Now, so with this, just we will solve one question, then we can close. If the function f of x is x square minus 2, then find the differentiation by using first hand. It is called find the derivative question. Find the derivative of f of x is equals to x square minus 2. They will give by using first principle.
Okay.
They will give this. Then we have to tell that it is a derivation. More of derivation is just calculating the limits. So can we find derivative by the given data? Find the derivative of f of x where x square minus 2 by using the first hand principle.
Yeah. So limit, sir. So we consider
here it is the graph, right?
Right.
If I told derivative means you have to find the slope. That's one thing we got clear, right? So now for this curve, this is also a slope, this is also a slope, this is also a slope. All are different values.
Yeah.
So means they have to mention at which point you have to find the slope. Otherwise, you have multiple slopes.
Okay.
Whether you want slope over here or slope over here, slope over here.
Yeah.
They have to tell, right?
Right.
Means whether you have to find the slope at x equal to 4, at x equal to 8, or at x equals to 12. They have to tell.
Okay.
Then only you can find the slope at particular point, because for a curve, it is x square minus 2 means it is a U-shaped curve. For this, there will be n number of slopes. We need slope at one particular point, not at all. We can't find directly. We need to find slope at one particular point. Okay, so let us suppose at x equals to 8.
Okay.
At x equal to 8, we have to find this.
Okay.
Now it's same thing, just you have to use this formula. Derivative, first you have to find the derivative, then you have to substitute. Okay?
Okay.
First write the formula. Derivative f dash of x equals to limit x tends to 0, f of x plus h,
x plus minus f of x
minus f of x divided by h. Here it is not x tending to 0, it is h tending to 0.
H. Oh yeah.
Okay.
Okay.
Now just substitute. What is limit of h tends to 0? We have to find a value of x equal to 8, right? That is f of 8 plus h minus f of 8, that is f of x divided by h. Right? Now just is a calculation. Limit h tends to 0. What is f of 8 plus h?
What is f of
8 plus h? F of x is x square minus 2. F of 8 plus h means instead of x you have to substitute 8 plus h. That's it.
Oh, okay.
8 plus h whole square minus 2. Right?
Right.
X minus 2. So x8 plus h whole square minus 2, right?
Right.
Minus
62.
Just keep it over here. F of 8, 62.
Right.
That is 64 minus 2, that is 62. Right?
Right.
Divided by h. It's all in the calculation. That's it.
Oh, so I got a 16h plus h square by h.
16h plus h square by h.
So if I take h common, can I do that?
If you take h common, yeah.
Yeah, so we'll get 16 plus h by h.
16 plus h into h by h, right?
So, yeah.
So h cancels. When you substitute h to 0, we will get the answer as 16.
Yeah.
This is the differentiation. of
Okay.
x square minus 2 at x equal to 8.
8.
Okay.
Okay.
So it went. Now in the same way you can do for any function. If they give, just you have to use this formula. Limit h tends to 0, f of x plus h minus f of x by x.
H.
Okay.
Okay.
This is the formula that you have to use for finding by first hand principle. Okay.
Okay.
But we are using that f of x equal to x, and we have many different expressions we will get with different powers, right? With higher
Right.
powers and all. So for each and every question, we can't be sitting and we can't derive in that question.
Right.
So that's why what we will do is, here also we have the standard derivatives. Okay.
Okay.
This one we have to remember. Today we will study 4. Not study 4.
Okay.
You have to remember these 4 today. We will remember 2 in each class or 3 in each class. And that's it. It's enough. Otherwise, if you remember all at once, then we will forget all at once. That's why.
Okay.
So first, the 3. Derivative is represented by d or f dash, right?
Yeah.
So here I am writing only the functions. So derivatives of. So first, x to the power n. Okay, this is the first formula. So I can take it as, you can write it as f dash of x power n, d of x power n. Okay, both are same.
Okay.
So the formula for this is, after deriving by using first hand principle, we arrived at this conclusion. X power n, that if you do the differentiation, we will get n into x to the power n minus 1.
Oh, okay.
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 So now with this, whatever the power it may be, they may give x power 8 plus x power 5, 3x power 5 plus 4x. If you have to do by using limit, it becomes very big. You have to use x plus h whole to the power 8, x plus h whole to the power 5. It becomes, I can't think even of it. It becomes very big, right? So that's why you have the direct simple formula. F dash of, if you do the differentiation of x to the power n, always it comes as n into x to the power n minus 1. Okay.
Okay.
Now the differentiation of a constant is 0. Okay.
Okay. Okay.
Now with this, let's see the previous question. What is the previous question? F of x is x square minus 2, right?
Right.
So at x equal to 8, correct? Now let's see.
Right.
What is the f dash of x? So when it's differentiation, two functions, you have to do differentiation for both separately. When it is addition and subtraction, okay?
Okay.
Means you have to do differentiation for x square and differentiation for 2 separately. So what is differentiation of x square? By this formula. X power n is n into x to the power n minus 1.
Yeah.
Differentiation of x square. 2 into?
So 2 x into 1.
2 minus 1.
To the power 1. Yeah. So 2x.
So it is 2x. What is differentiation of 2?
0.
0. So it is 2x minus 0, which is 2x, right? This is the differentiation f dash of x.
Yeah.
Now we did at x equal to 8. Just substitute. 2 into 8. 16.
Oh, okay.
The same answer.
Yeah. Yeah.
Instead of doing the whole limit and all, with just one step, you will get the answer. Okay.
Okay.
That's why these formulas are very most important in the sense, not only for maths, in physics also we will use this.
Okay.
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 So x power n is n into x to the power n minus 1. And the differentiation of a constant is 0.
0.
Okay. Just remember these two formulas today.
Okay.
Not to remember the second one. Differentiation of a constant. If you want to understand this one in graphical notation, constant means this y equals to 5, y equals to 8 something, right? This is the graph for this, right? What is this slope? Derivation is nothing but tan theta, correct?
Right. Yeah.
What is the theta over here? It's one single line.
0.
There is no theta, 0.
Right.
So theta is also 0. Theta 0 means slope 0. Slope 0 means dy by dx is 0. That is differentiation 0.
Okay.
If you don't want to understand it in this method, just take y1 and y2. It's very simple. Here it is y1, here it is y2. x1, x2. What is y2 minus y1? Both are same, right? 5 and 5.
Right.
So it is 0. 0 by anything is 0. That's why the differentiation of a constant is 0. Okay?
Okay.
That's it. Just one question. If it's okay for you.
Yeah, sir, no problem.
Yeah. This one. What is the differential? Okay, if f of x is root x. Okay, instead of root x, we will take simple one. 1 by x. What is the differentiation? F dash of x equal to dash.
So it will be 0, right?
Why 0?
Because they'll give like, it'll be a constant, right?
It is x. X is a variable. There is constant.
Right.
I can write
so like
x as. Yeah, tell me.
No, like it'll be x will be like some like value, right? Like a number, right?
No.
So
Now we are
1
finding.
by
Now we are finding generalized derivations. That's it. Previous also we found out generalized ones only. Then we are substituting at that particular point. We are substituting the value of x. Okay.
Okay.
Now here, remember, I think I know what you are thinking. Since it is 1 by x, you are giving the differentiation for the numerator, differentiation for the denominator, right?
Yeah.
This is what you are thinking. Okay. This is not. We should not use that method in differentiation. There is a different formula for it. Okay.
Okay. Okay.
Don't use that. There is a different formula. It is applicable only for limits. It is not applicable for derivatives.
All right.
So I can write 1 by x as x to the power minus 1. Is it correct or wrong?
Right. Yeah.
It is
correct.
in this form. That's it. X
Okay,
is x,
so
n is minus 1. That's it.
okay.
So by the formula,
So that's n. There'll be minus 1 into x to the power minus 2
which is,
minus 1 by x square.
that's it.
Right. Okay.
Now if they ask at particular point, just you have to substitute it. That's
Substitute
it.
the value.
Okay.
Okay.
Wherever there is 1 by x, just take it as x to the power. Thing. Now, okay, the last question. F of x is cube root of x. Then what is f dash of x?
Uh, 3x square, right?
3x square. If f of x is x cube, then what is f dash of x?
N into x to the power n minus 1, right? So 3. Yeah, 3
For
x squared.
both, I am getting the same slope. How is that possible? If the graphs are different, the slope should be different.
Oh, wait. So, no, I thought you were asking for, okay, for x cube. I
This
didn't
is
know it was 3 root
cube
x.
root
Yeah,
of x.
sorry. Yeah, sorry.
Yeah, proceed. X to the power 1 by 3.
Yeah.
That is the cube root, right? 1 by 3. Then by proceeding the formula, 1 by 3 x to the power 1 by 3 minus 1.
Yeah.
Correct?
Yeah.
1 by 3 x to the power minus 2 by 3.
2 by 3.
So what we got over here? 1 by 3 into
1 by x to the power
root
2 by
of
3.
x square.
Yeah.
Otherwise directly you can write 1 by 3 into x to the power 2 by 3. It's the same.
3.
Okay.
Okay.
So now if you remember this, what is x power differentiation of x power n?
N into x to the power n minus 1.
N into x to the power n minus 1. Okay.
Okay.
And differentiation of a constant is 0.
Is 0.
And if they ask what is the first principle, limit of h tends to 0, y2, that is f of h plus x minus y1, that is f of x by h.
By h.
This is f dash of x. Okay.
Okay.
That's it for today. And telling again, you have to remember the formulas.
Yeah.
If you forget the formulas of derivatives, it's fine. I will agree. No problem. But you should not forget these formulas for derivatives. Okay.
Okay.
Because you can derive the limits by this itself within 1 second. That's why these are important. Okay, that's it.
Okay, sir.
Yeah.
Thank you.
Yeah. Bye.
Bye.